Okay, YouTube, in this video we're going to focus on finding the quotient of two complex numbers in polar form. And the thing is here, with division or a quotient, this is going to be the inverse operation of a product or multiplication. So that is to say that from our last video we said if we had two numbers, we'll call these in polar form R1 CIS theta 1. That'll be our Z1 here. And if we were to take that times a Z2, multiplication wise we have R2. Let me get that fixed here. R2 CIS theta 2, if we were to multiply these together, remember that the product of these two things, Z1 and Z2, okay, would be equal to the product of their modulus values here. Basically multiply the R values out in front, and then what we're going to do is add the angles. So we say theta 1 plus theta 2. So the fabulous thing about the fact that multiplication is the inverse of division means that we're really just going to perform the inverse operations of what we did over here to find the product in order to find the quotient. So let us represent our numbers here. We're going to say Z1 is R1 cosine theta 1 plus I sine theta 1. And so I'm also going to abbreviate this here as R cosine I sine of theta 1. Since they mean the same thing, we say this is our Z1. Our Z2 we're still going to allow to be our R2 times the cosine I sine of theta 2. But we'd say that if these are two complex numbers in polar form, then their quotient Z1 divided by Z2 would be the same thing as R1 divided by R2, and then we would subtract our arguments here. And in subtraction, order matters. And so one thing we're going to say here is 1. We're going to divide the modulus values. And so we're going to say that order matters here. And so basically, if we're dividing complex number 1 by complex number 2, we're going to take modulus 1 divided by modulus 2. And then the same thing is true for our arguments, except for what we're going to do with our arguments here is we're going to subtract our arguments. And, again, order matters here. So we say order matters. And basically what I mean to imply is that we have to take our argument from the first number that is being divided and subtract off the argument from the second number that is the divisor. Excuse me. So we say that to divide two complex numbers, we're going to divide the moduli and subtract the arguments. Pretty simple thing to do. So looking at these two examples you see down here, I'll work through this first one with you, then I want you to pause the video and try to find this quotient over here. But let's say, for instance, we have a Z1 and a Z2, and these are both in polar form. Then the quotient Z1 over Z2, let's go ahead and rewrite these here. We say Z1 in abbreviated form would be 12 CIS 3 pi fourths, and then we have Z2 would be 4 units, CIS pi fourths. We're on a pi fourth direction here. So if we're going to find the quotient, there we go, quotient between Z1 and Z2. Basically what I want you to see is that we would start by just saying that we have 12 CIS 3 pi fourths divided by 4 CIS pi fourths, and what we're really going to get according to our rules from up top here is we're going to get 12 divided by 4 first. And we're going to take this times the CIS of the first angle here, the number being divided's argument, 3 pi fourths, minus the second angle or second argument from the number that was dividing the first. And so really, we divide the arguments, we get 3, and then we'd divide the moduli, and then subtract our arguments here. We would be left with 2 pi fourths, or in other words, we could say that this quotient here really is 3 CIS pi halves when we simplify our 2 pi fourths. So our quotient is this value right here. Now, could we have performed this mentally? Actually, I'm going to argue that we can. And so go ahead and try this one on your own here. Go ahead and unpause it when you're ready to see the solution. But when you are taking a look at this here, we'd say Z1 over Z2. If we were to do this really simpler, and in a simpler fashion, we say 50 cosine 4 pi thirds plus I sine 4 pi thirds. If we're going to divide that by this over here, we'll divide the moduli first. So 50 divided by 5, and then we'll just subtract our arguments here. Since we're taking Z1 divided by Z2, we're going to say CIS 4 pi thirds, which is the angle in the first argument, and subtract out the angle in the second argument here. And so what we end up with is really just 10 CIS. And I suppose 4 pi thirds minus 1 pi third would be 3 pi thirds. So we'll go ahead and simplify this also, but the quotient of these two numbers is 10 CIS of pi, just a single pi here. And so one thing I want to point out here is that it does ask us to leave our answer in polar form. As we work further into these videos, we're going to work on then taking our answers that we get in polar form and also converting them back into rectangular, or what we call standard form. Cheers.